Hi everybody. Today we have a section on actually solving some equations that have square roots in them, since math is all about solving equations. Last section we just talked about what a square root was. So today we want to actually solve some equations with square roots in them. All right. So this is pretty straightforward. So we're just going to jump right into exercise 1 here, and it just simply says solve x squared equals 169. And just like any other equation, our job is to get x all by itself. All right, and right now it isn't by itself. It has this little squared term there. All right, so from last time, if we think of what is squaring and square rooting, well, one undoes the other. All right, just like if we had the equation x plus 4 equals 6, well, how would we solve for x? Well, we do the opposite. We want to get rid of that 4. We want to move it to the other side. And the way we get rid of it on one side of the equation is we undo that plus 4. So I would subtract 4 there, and whatever I do to one side, I would do to the other, and that means those would go away. They would go to 0, and I'd have x equals 2. So we want to do the same thing with this equation, all right? And I'm just going to rewrite it right there so I can add something to it. I want to solve for x, meaning I want x to be all by itself. Well, to do that, I square root. So if I take x and I square it, right, and then I square root it, well, what am I left over with? I'm left over with x over here. Well, if I'm going to do it on one side, just like I did over here, if you do something to one side of the equation, you want to do the same thing to the other side of the equation. If I take the square root of 169, that is 13. Now, one little wrinkle here. When you square root a number and you're working with equations, you want to consider every possible solution to this equation. So you could have a positive 13, because 13 times 13 equals 169. Or you could also have a negative 13. All right, because if I take a negative times a negative, I also get a positive. So I'm going to write this. I'm going to say positive or negative. That little symbol right there means positive 13 or negative 13. Either one of those will work. So there it is. I've solved for x on both sides, all right, or on one side of the equation. All right, so it's really that simple. All right, let's try this next one here. If I can get rid of that, there we go. Exercise 2. A sandbox is in the shape of a square, so I'm going to draw myself a square. And since it's a square, again, from the other day, I'm going to put these little symbols in here. I'm going to put little hash marks, and that tells me those are all the same size, right? And it says the area of the sandbox is 625 inches squared. Notice I have that little inches squared there because we are talking about area. So I might as well start out with the area of a square formula. All right, a equals s squared. All right, and it says what is the length of one of these sides? Well, so I want to know what s is, right? Each one of these sides is equal to s. All right, so I could label that over there if I want. Well, they tell me that I have 625 square inches in area, so I'm going to plug that in right in for a. All right, and I still have this s squared. Well, this is just like the problem from before. I want to solve for s. All right, so I have to get rid of that squaring. So I'm going to square root over there. And if I do it to one side, I better do it to the other. All right, so what is that going to leave me with here? All right, and if I know a bunch of my perfect squares, then I probably could do 625 and I could square root it. But if I don't, I just go to my calculator and I want to take the square root. I want to take the square root of 625. So let's see, if I take the square root of 625, and that is, oh, I got to do that second, sorry. Boom. Okay, that's 25. All right, so I get 25. Different calculators work a little different ways depending on what calculator you have. So there it is. Now there is a unit. There is a unit onto this. So since this is the side of a square, I'm just going to put 25 inches. And you may remember from the last exercise I had plus or minus. Well, it doesn't really make sense to say a negative 25 inches in this case, so I'm only going to put down the positive value. All right, so again, very, very straightforward, just solving for x. They do get a little more involved if I turn on this one. Oh, actually, this one isn't really any more involved than the other one. All right, so let's solve for x squared here, or let's solve for x, I should say. And I'm going to, again, square root both sides. And I don't believe that is a perfect square. I'm going to call up my calculator here, and I'm going to take the square root. Oops, I don't want to take the square root of 25. I want to take the square root of 324. Hit equals, and oh, that is 18. Okay, all right, I didn't know that one off the top of my head like I should have. All right, so x equals 18. And again, there's no units on this. There's no application, I should say. It's not a picture. It's not a distance or anything. So I'm going to put plus or minus 18, because if I multiply 18 by 18, I get 324. If I multiply negative 18 by negative 18, I also get 324. All right, so hopefully those are pretty easy for you. All right, let's take a look at the others that we have here. We have this one. Now, this is a little different. Now we have, notice we don't have squared anymore. We have, oops, we have a cubed. All right. Well, how do you undo cubing? Well, just like you undo squaring, you square root. Well, you can undo cubing by cube rooting. All right, so let me put this one right here so I have a little more room. Okay, and I'm going to write this like this. We're going to cube root, which means I'm going to put a little 3 in there. Okay, and I'm going to cube root on both sides. All right, so if I take x and I cube it, and then I cube root it, well, I just end up with x. All right, and if I take 64 and I cube root it, I need something times something times something. Something times itself 3 times. That will give me 64. Now, if you think about 4 times 4 times 4, let's see, 4 times 4 is 16, right? And 16 times 4 is 64. So if I cube root 64, I get a 4. All right, so there's my answer. Now, I can't say negative 4, right? I can't say negative 4. Here's why. If I take negative 4 times negative 4 times negative 4, if I multiply these two together, I'd be positive, right? And if I multiply these two together, I'd be negative, okay? And that's not what I have underneath the radical. I have a positive, so I can't do that. I can't do a negative 4. All right, so that's just positive 4. Okay, a couple others here. I think these all are cube roots as well. Let's put this one on here. Now they talk about a cube, and notice now it's a volume of 27, not an area, because an area, they're just talking about 2 dimensions. That's why it's squared. But a volume, they're talking about 3 dimensions. And the thing we know about a cube, is that all of these faces, I can even put little hash marks in here for the ones behind here. All of these faces are the same in a cube. All right, cube has all of the faces being the same. So, what is the formula for the volume of a cube? Well, volume equals length times width times height. However, this is a rectangular prism. You know, it could be anything like this. All right, but in a cube, all of these are the same. So really, the volume is one of the sides cubed. All right, that's a really bad 3, isn't it? I'll make that a better 3. All right, there's a better 3. Okay, so this is for a cube. All right, and we get that formula from the rectangular prism formula. Oh, that's really bad too. Okay, let's make that better. Arrow. Okay. All right, so we're going to use this formula here. We're going to use this one, and they tell me that the volume is 27, so just plug in a 27. Okay, 27 inches squared, and that's just the units, so I'm just going to plug in 27 for now. And to undo that cube, I'm going to cube root. Okay, so S equals, what's the cube root of 27? Well, 3 times 3 times 3. All right, 3 times 3 is 9, and 9 times 3 is 27. So this would be 3. So each one of these sides, this is 3, this is 3, this is 3. All of these are 3's. Okay, and the volume of this cube is going to be 27, even the ones in the back. All right, so here's my answer right here, 3, and we better include the units. What is it? Inches, and we're just talking about one side, so that is 3 inches. Okay. All right, one more. Let me turn this one off. There we go. And we want the positive value. Make sure you read the directions there. We want the positive value of this guy. Now, whoa, this looks a little different here. All right, we have x squared. We're back to a squared equals 256 raised to the negative first. Now, what is that? Remember, all the way back in the fall, we said if you have a negative exponent, well, you can get rid of that negative exponent by taking the reciprocal of that number. All right, that starts out as 256 over 1, but it can turn into a fraction by saying it's 256 over 1. It can turn into the reciprocal. You take the you flip it, right? You take the reciprocal. So now it's something that you just do like we have been here. You take the square root, and you take the square root. Alrighty, so if I take x squared and I square root it, I get x. And, well, let's see. Now, this is a fraction under here. And here's what I can do with fractions underneath the radical. I can take the square root of the top over the square root of the bottom. And I should say numerator and denominator, right? Okay, so let's take the square root of 1. Well, that's pretty easy. That's 1. And if I take the square root of 256, let's see, is that one of those perfect squares? Is that one of those perfect squares? Let's see. Let's see, square root of 256. Ah, yeah, 16. All right, that's 16. So that is a 16. Whoops, there we go. And it is an equation, all right, and I'm just square rooting, so I would have the positive and negative value, 1 over 16. So there you have it. So we just want to be able to use this in equations, use this whole square root idea in equations. And in the future, we're going to make these equations a little bigger. Maybe you have to do a little algebra first and then square root both sides. And we'll get there. All right, we'll get there. So just a little intro on how to use square roots in equations, and it really is that simple, guys. So thanks for watching, and we'll see you in the morning.